About how we do DevOps. Who in the room has used us to order food? Great. Okay, so for the people that haven't, we're an online takeaway website. We're the online sales channel for our restaurants. We have thousands of restaurants around the country and 13 others. We put their menus online and then we take a cut of the orders that come via our website. It's a challenging problem, pizza, it turns out, because you go from potentially a completely anonymous customer to an online purchase, hopefully, and then the order goes to the restaurant. There's a little magic box on a GPRS network that we send the order to. It prints out and beeps. The restaurant accepts it, and then we're totally hands-off. We've got no insight at the moment into the fulfillment cycle of your restaurant down at the end of your street. It is literally that. And we promise to get you the food, still warm, 45 to 60 minutes later. We make this work more than 98.7% of the time perfectly. And we do it on Windows, which normally gets a laugh from a non-Windows crowd. We're cloud native in AWS, which is, I guess, maybe a little bit different from what you might expect of a Windows environment, Azure being what it is. And we have very predictable load. Who can give me a guess when we get busy?
Friday night.
What time of day?
After dark.
Yeah. So it is literally, hey honey, do you fancy cooking? I'm on my way home, and oh no you don't. So it's we'll order a takeaway, or it's literally that. We love rainy days. We love the winter because people don't tend to cook as much. And so yeah, it's very predictable. There's a daily cyclic, there's a weekly cyclic towards the end of the week, and there's an annual cyclic. So we're busier in the winter months. Winter is coming. We're a technology team inside of a large, I guess about 1,200 people in the company. Of that, about 200 are in the technology team. So product managers, engineers, UX, UI, that kind of thing. We're, I guess, reasonably high volume. We do about 1,200 orders a minute of actual customer load, and then we add another 50% on top of fake load every peak time to prove that we can do that ongoingly. We're a predominantly Windows-hosted platform, so most of the money-making stuff is written in C#.net, and all of the rest is cross-platform, so things like traffic routing is done with HA proxy, stats and so on are done with Statsky and Graphite, because why would you use Windows for that stuff? There are free alternatives. Most automation is Ruby. We're moving more and more of that for the Windows stuff to PowerShell, and we're learning how to do that as we go along. And we're splitting up the monolithic system into a bunch of reasonably loosely coupled APIs, or at least we like to tell ourselves they're loosely coupled. Some of them are more loosely coupled than others. And we're doing that incrementally with no big rewrites. We're not microservices, but we're moving in that sort of general direction. To make this work, you have to have, or we had to have, a cultural change. So I started in 2010. We knew shit about the platform. We didn't know how to deploy it. We didn't know how to test it. We didn't know how to build it even. We didn't know, or in fact we did know that what was in source control was not on our servers. So we had to figure out what was on our servers and how to build it, and which developer's workstation is the safe one to build it on, that sort of thing. We had a Snowflake server, and it was horrible. We did maybe 10 deploys in the year that I joined, 2010. My first day, January the 4th, was spent figuring out why we'd fallen over on January the 1st, our biggest day in Denmark, biggest day of the year, at the grand total of 2 to 3 orders per minute. We did find out, and as I mentioned, we now do sort of 1,200 orders a minute at peak time in the UK without even really thinking about it. We did maybe 10 deploys that year. Last year we did more than 800. This year we stopped counting because it's a vanity metric. We deploy lots of times a day. So there are a few rules for this to work. The teams, they have autonomy about what they work on within certain constraints. I'll talk about the team organization in a second. But some of the rules for components are you don't break backwards compatibility, but of course you can, because most of them are internal, and so as long as you tell your dependents that you're about to do that, that's kind of okay, as long as you do it before you actually deploy. That's a bit hit and miss sometimes. And you can use what you like for your components. You know, it's predominantly .NET, but if you want to use, say, Nancy instead of Web API, or you want to use this test framework instead of that one, then go nuts. But you're supporting it. So you have to convince at least your team to buy into that decision. And then the other rule is other teams that don't own your components have to be able to launch your components in their pre-production environments. And if they can't, then they're going to come over to you and sit on your shoulder and say, hey, how does this work, how does this work, how does this work, and interrupt and bug the hell out of you. So that's how we police that. The tech organization structure, we've changed this reasonably recently. It used to be, well, it's still 2 pizza teams. We like our food analogies. So small teams, reasonably independent, reasonably cross-functional. And it used to be the fact that a team would own, say, half a dozen of the components of the platform, lock, stock, and barrel. Any work that had to get done in those components, the team does. So that means that you have dependencies between teams because Team A wants Team B's stuff to change. And they're not necessarily the people that know how to do that, so they have to wait for Team B to do it. So we've reorganized. Now every person in tech is a member of 2 teams. One is a team centered around a business objective, focused around a business objective, like the ones you see there. And the second team that you're in is the component ownership group. This is the team that is operationally responsible for some of the components themselves. So the 3 S's, scalability, security, and sustainability, are what the cogs deal with. There's a cog for consumers, there's a cog for the restaurant stuff, and then there are specialist cogs for the native apps, because they're specialist knowledge. So the slides are probably a little bit odd. And then we also have a platform as a service team, a platform engineering team. They are not an operations team. Increasingly, they own the road to production. They don't own production itself as a thing. They own some of the foundational stuff that we need to get to production, like the deployment service, like monitoring and alerting, like centralized logging, the ELK stack. They own the creation of the base machine images, but they don't own production itself. They're not going to get alerts for your code. You are. We have a bunch of principles that we try and adhere to. I never remember all 5, so I put them in the speaker notes. Do the right thing, take responsibility, be transparent, continuously improve, and take pride in your work. Those are the things that we want our engineers to do. Those are baked into the culture. And I mentioned that the teams have autonomy about what they work on. That's still true in the new world where you're in 2 teams. It's just there's a bit of friction between whether you're working on features versus whether you're working on operational concerns. If production is on fire, then obviously work on production to fix or mitigate or remediate the changes, the problems. And then there's a set of tools. DevOps is not about tools, but they do help. I mentioned developers get alerts. We recruit competent developers, and then we find that a lot of them don't necessarily have a set of skills that you want when you're operating in production. So we teach them that. I find that I have a lot of success suggesting to developers that checks, alerts, they're just continuously running tests in production. And you write tests, right? So now you write these things as well. So response time checks, SLAs, content length checks. Those are standard ones that we end up writing. The cogs have an operational support rota. They have the autonomy to decide who's on call at a particular point. It tends to be that you're on call for a week at a time for those components, but you can swap and change. That doesn't matter. You self-organize whatever makes sense, as long as you're on. There's coverage during core hours, and it's quite nice in the UK because it's not 2 a.m. at night. It's at least sort of general even. And engineers, if there's a problem in production, they have the autonomy to do the root cause diagnosis, fix it, so it doesn't happen again. New problems are fine, but old problems that keep recurring are boring, so we don't want those. Things still break all the time. I swapped into this speaking slot at the last minute, and yesterday we had a critical incident that I'm going to have to rush off to. So yeah, stuff still happens, but we know about it now. We have this monitoring, we have this alerting, and so we know pretty much ahead of the customers that there's a problem, and we might have fixed it before they notice. That's in contrast to back in the 2010 sort of era, where the customer would tell us about the problem and complain about it on social media, and that would be bad. We don't have an operations or, I guess, NOC team to do this for us. That team of adults that will pat you on the head and say, no, you have to roll that back now. We don't have that. We will actually warn our call center who are on the call face about, I know, a payment provider is down and we are swapping to the backup, or a payment provider is down and so is the backup, we're swapping to cache, that sort of thing. We're starting to do things like write down operational runbooks, and then we're starting to automate the steps to fix things from those runbooks. We're also discovering that feature toggles are not just for launching new stuff, they're for turning off new stuff. If you leave the feature toggle in, you end up with more complicated code, but you do then have the option of falling back to the previous feature if it goes badly, and it's still there. So there are a few, I guess, tools, enablers, game changers that helped us make this work. We've got persistent group chat. We use HipChat. I guess you can use Slack and IRC. We've got a bot inside of HipChat that does some of the stuff, like you can raise a PagerDuty with that if you need to. We've got almost real-time monitoring. We use StatsD, Graphite, Grafana. We've got almost real-time alerting. We use a thing called Sarin, which just listens to Graphite, runs Graphite expressions, and decides whether to bother you or not. We've got the ELT stack for logging, and now that we've bled all over it, we know how to run Elasticsearch. And so we're starting to use Elasticsearch for actual feature delivery. We separate deploy from release with feature toggles a lot, so we deploy, and then turn it on. And obviously we're hosting in the cloud, so we have infrastructure as code, and we have tests for that, and it lives in source control, and you can see when it changes, not just hear about when it changes because you just got a page because it changed and you didn't realize. I guess, like a lot of data centers, ours, before we moved to the cloud in 2013, was a total fucking mess. We had Snowflake servers. We didn't have any config management because, Windows back in 2010. We didn't write things down. We had a wiki, but it was more of a case of go and talk to this person to find out how this works, as opposed to this is how this works. We didn't have much in the way of automation, either at the infrastructure provisioning side or at the deployment side. The deployments were done lovingly by an ops team at the time, and they didn't love us at all. We didn't have any monitoring. We would run SQL queries and schedule a SQL query to do that and push that into a Confluence SQL-driven chart. So if someone refreshes the wiki page, then the system runs slower. Yay! We had monolithic apps, and we still do to some extent, but we had bigger ones then. And we didn't have much fast-running test coverage. What we did have, because I put it in, was decent continuous integration once we pushed that to the whole platform in 2010. So I guess before AWS, the architecture looked roughly like this. We have our data center and we have our platform in the middle. And then we had bits of it, like backups going to S3, that sort of thing. Sorry about the slides, I'm not sure exactly what's happening with that. And then after the AWS migration, it looked like this. So obviously you can see the improvement there. Sorry, just a quick show of hands. Who's familiar with AWS? So, okay, great. I won't explain bits like I was expecting. We have a VPC, our own very private cloud, virtual private cloud. We have a public subnet and a private subnet per availability zone. So we have 3 of each in EU West 1. Most things that we run, well, in fact, all things that we run happen in an auto-scaling group, and most things happen in the private subnet, and a few things live in the public subnets. Very standard, nothing really to see here. We've got a NAT at the edge, so we can get out. We've got an internet gateway, so the internet can get in, and we've got a direct connect VPN gateway, so the office can come in to the private. When we decided to migrate to AWS, we made a few decisions up front. You know, what's the point of moving to the cloud if we don't do this stuff? So we want infrastructure as code, source control that. We want it running in continuous integration. We want to be highly available by default. We want to be able to weather the loss of a single AZ, not just a single server, but a whole availability zone. And for customers to not notice. That's not to say I won't get paged if an AZ goes down, but customers won't notice. We want everything to be a pull deployment by default. So we don't necessarily want a central authority like a Chef server or a Puppet server or a cluster, because we'll then have to scale that and make sure it's highly available as well. We want just to pull a package from S3 and for CloudFormation to decide what to do with that when a box boots. And we want individual servers to be expendable. We want cattle, not puppies. Love that phrase. So this has been working quite well. We run a few hundred instances at peak time. We automate scaling so that it happens roughly on a schedule rather than by reactive scaling based on alarms. It's very crude, but it works really well for us. And I guess moving to the cloud forced us to do some architecture that we hadn't previously. It meant do some engineering to do it well. So you know how in your code base you'll decompose things to single responsibility principle and you'll be object oriented. We applied those concepts to the platform, and we arrived at this imaginatively named concept of a platform feature. So for example, the public API is a platform feature. So is the desktop website. So is the API that deals with consumer logins and authentication signups, that sort of thing. Lots of reasonably small, disparate SOA things. There are websites, there are internal APIs that are, well, still websites, and there are Windows services to do worker jobs. We almost made that decision up front. We arrived at that sort of halfway through the sort of 6-month prototyping migration. So a platform feature is defined with a CloudFormation. CloudFormation is, I guess, config management for your AWS resources. It's a service that AWS provide, and essentially it means that you write a JSON file, or you give AWS a JSON file. Within there's a set of parameters and a set of resources that you want AWS to make for you. You hand AWS the CloudFormation, and it goes off and makes those things. It takes a while. It's much faster than it was. Everything is a pull deployment. I mentioned everything pretty much runs inside of its own auto-scaling group. Autoscaling is the best cron job ever invented. It will basically continuously monitor how many servers there are in the group, and if it drops below how many I want, it will create more. And it creates more according to an infrastructure as code recipe. That includes some CloudFormation init provisioning steps, bootstrapping steps. So our servers will take about 7 minutes for AWS to ready them for us, and then a few more minutes for CloudFormation to run through the bootstrapping. The bootstrapping is where we download our code, unzip it, and deploy it onto the server and start serving traffic. No state is kept on an instance for very long. So logs are shipped, stats are published to JustEat, performance counters are part of that. Data is certainly not saved to instances, with the exception of data instances like our SQL Server, like, actually no, just like our SQL Server at this point. And basically there are very few reasons for an engineer to log on to a box. And so we don't do that. We want people to be able to debug their code, or effectively debug their code, not actually hook the debugger on, in production without remote desktopping to a machine and actually having a look at things. And at the moment, no external actor can tell an instance to do something to that server. So a server will bootstrap, and then later be terminated. For the lifetime of the server, it's pretty immutable. That brings me to the worst thing about being in the cloud. Deployment now takes 20 minutes rather than 5 weeks to get new servers. So 5 weeks, I can go away and do something useful. 20 minutes, is it done yet? Is it done yet? Is it done yet? Horrible. First world problems. This is a platform feature in a picture. You've got your template on the left, and then that gets instantiated into the VPC. It's got some DNS, it's got an elastic load balancer, it's got an auto-scaling group. That creates some EC2 instances, and it talks to SQL. That's the standard sort of, I guess, composition of a platform feature. Although the more recent ones, we're starting to not talk to SQL Server, but talk to our own APIs, or to hybrid data storage like DynamoDB, or like Amazon RDS, as we break apart the monolith that is the SQL database as well. The servers. So Windows 2012 R2 core, not GUI. We have several baseline servers, server builds I should say. There's one for the workers, there's one for the webs, which is basically the worker plus IIS, and there are a couple others. Reasonably recently, we actually went to the trouble of writing a build script for the servers. We chose Ansible, whereas before we would just build it by hand back in 2013.